I'm Paula Hong. I'm a senior applications chemist at Waters Corporation. I work in the separations laboratory, testing new technologies and talking with chemists about the challenges you face using analytical instruments. One of my current projects focuses on the ways to make the development of chromatographic separations more effective and more efficient. Over the years, we've all become very good at screening through organic solvents and reverse phase columns with different properties to achieve our targeted selectivity. We routinely adjust temperature and gradient slope to improve resolution. In many cases, we take advantage of the stability of modern columns to screen both high and low pH mobile phases. However, it's uncommon to test small incremental changes in pH as a routine tool in methods development. In this example, which is based on a USP method, you can see the dramatic changes that can occur with small modifications of pH. Elution order can change over a range of just 0.3 of a pH unit, and if you inadvertently choose the wrong pH, you'll see coelutions. So while it certainly can be valuable to use pH adjustment to develop a rugged method, chromatographers don't frequently use this approach. Part of the challenge is that preparing mobile phases of different pH is labor-intensive and time-consuming exercise. At Waters, we have been working on ways to use our quaternary acuity UPLC H-class system as a tool to automatically blend buffers to control mobile phase pH. Our technique is based on the established principle of acid-base equilibria, where a buffer of desired pH can be created by mixing solutions of a weak acid and its corresponding salt or base. To accomplish this, first we configure the instrument like this one. The 4 solvent reservoirs are used to control both the pH and solvent strength. Reservoir A in this instance contains 125 millimolar formic acid and B is 125 millimolar ammonium hydroxide. The pair is used to control pH. Reservoirs C and D are used for water and organic solvent, respectively, to control solvent strength. We can program the desired pH and solvent strength into the method by selecting the required percentages of A, B, C, and D. And the values can be changed as a function of time to form the gradients. A sequence of different methods can be used to screen alternative values of mobile phase pH. We've been developing ways to make it even more easier and more efficient to use chromatographic principles. AutoBlend Plus is a technology that is included within the instrument operating software of the Acuity UPLC H-class system. AutoBlend Plus allows us to directly program the method in units of pH and solvent strength. It can also be used in methods for both small and large molecules. As you can see here, the instrument method does not contain percentages, but permits direct entry of the desired pH. You can program different methods at different pHs without making new buffers or changing bottles. The software algorithm calculates how to deliver the required pH based on the definition of a buffer system. That can include the pKa for the selected buffer, or it can be based on an empirical table. The empirical table essentially calibrates the AutoBlend Plus with any pair of buffer components that is useful for the separation. Currently, we are using this flexibility to create buffer systems and mixtures of buffers that cover wide pH ranges and that are compatible with a variety of detection systems. To summarize, we began by considering the importance of small adjustments in mobile phase pH for developing chromatographic methods, and then learned how the chromatographic system can make the use of that principle more efficient and less labor-intensive. To learn more, go to waters.com/autoblend. I'm Paula Hong for Waters Corporation. Thank you.